let's talk about some elementary concepts right now that students are often are not very comfortable with. Let's go with the very first one. Let's take 5/11 minus 1/10. 5/11 minus 1/10. What do we know about fractions? We know that when we have adding or subtracting of fractions, we have to have what was called a common denominator. And so we learned about how to find common denominators back in elementary school. You also have learned what's called the butterfly method, and so that's what I'm going to teach today. So here's how the butterfly method works. We always start with this slant that goes initially from left to right downwards, and I say 5 times 10 is 50. And then I ignore the symbol, whether it's addition or subtraction, and I do the second diagonal. 1 times 11 is 11. Now directly in between them will be whatever this part of our butterfly is. So our butterfly is a negative sign in the head. Down below, I'm going to push, in this part of the butterfly, I'm going to push these together and multiply. 10 times 11 is 110. Now what is 50 minus 11? Well, I know 50 minus 10. 50 minus 10 is 40, and I need one more, so I have 39 over 110. I'm feeling pretty confident about that, but I can see, can this be simplified even further by going 39 divided by 110 and hitting math fraction, enter, enter. We can see it cannot be reduced. All right, so how do I do this very elementary task? And remember, sometimes there's more than one way, like there's more than one way to factor a trinomial when it is factorable. There's more than one way to do fractions. It's important for us to know both ways that I'm presenting, and I'll tell you why as the problems get harder. So in this situation, one way to do this, and I'm going to show you both ways, is to do what's called the butterfly method. 3 times 3 is 9, and 1 times 8 is 8. I'm going to drop down the symbol subtraction, and then 8 times 3 is 24, 9 minus 8 is 1, and I have 1 over 24. Okay? Now, I was taught this method. This is the way I was introduced. I didn't even know the butterfly method until I was like 10 years into teaching. Here's how I was taught. What's the smallest number that 8 and 3 both divide into? 24. So I was taught times 8 times 8 times 3 times 3. So 9 over 24 minus 8 over 24. Okay, I can put them together now because I have a common denominator, and I get 1 over 24. How many of you were taught the second method, hands up high? There is absolute value in knowing both ways, and I'm going to tell you why. I'm going to share with you today why in certain situations it's advantageous to use butterfly, and then we're going to call it the old school method, okay? So let's look at number 2 right now. In my opinion, number 2, you could use either method. Either method would work. So when I say go, number 2, I believe it's up to you and your preference on whatever you can do best. All right, I'm going to demonstrate both in case one makes more sense to you. So I'm going to butterfly this right now. I have 7 times 11 is 77. 2 times 3x is 6x. In between, I dropped on the plus sign, and when I multiply, I get 33x. Now, here's the deal. Can I do anything else? Because that matters. We have to be fully simplified here. And so I'm asking myself, is there anything more I can do here? So the only thing that I would think of is, what are the factors of 6? That's what I would think of. What are the factors of 6? 1, 2, 3, and 6. And I want to know if any of those numbers divide into 33 and also into 77. So let's start with 6. We always start with the largest one. 33 divided by 6. Okay, that doesn't work, so that's not an option. 33 divided by 3 does work. Okay, let's see if it works for 77. 77 divided by 3, that doesn't work. And I know 2 doesn't work because 77 and 33 aren't even, and divided by 1 doesn't matter. There we go, we're done. And I could have also achieved that the old school method, again, recognizing I could take 7 times 11 and 3x times 11, 2 times 3x, and 11 times 3x, and that's how to have 77 over 33x plus 6x over 33x, and then I combine them. Again, to me, it seems like sometimes this is a longer process, and here's a perfect example. I want you to look at number 3 right now, and let me press pause. So when I look at number 3, I recognize that this breaks into x plus 3 and x minus 3. And you may be wondering, Miss Bradley, how did you know that? Because I know 1 breaks into 1 times 1, x breaks into x times x, 9 breaks into 3 times 3, and with this it's called the difference of squares. Square, 2 things times itself, the exact same value. It only can occur, difference, it only can occur when you have subtraction. So right now, in my opinion, there's definitely an easier way. And so that's what my goal is today and tomorrow, is for you to learn the easier way. I I think there's a definite way to do this that's going to be a lot faster. Ultimately, if I can get a common denominator, this is pretty easy. So when I look right now and I ask myself what would be needed to have a common denominator, well, I can see they both contain x plus 3. So if this group had x minus 3, and remember, whatever you do to the bottom, you must also do to the top. Now I have a common denominator. Now life is pretty easy. So I'm going to go about doing this one using the old school method. So now I have a common denominator of x plus 3 and x minus 3. Now on the left-hand side, there's a 3. And on the right-hand side, before I write this down, I'm going to just distribute right now. 5 times x is 5x. 5 times negative 3 is negative 15. Okay, when I combine like terms in the top, I have 5x and a positive 3, and a negative 15 is a negative 12. And I don't have to FOIL or distribute the denominator. This is right now in what we think of as a condensed form or simplified form. Look at number 4, and we're trying to decipher what would be a good common denominator. We could do, there's nothing wrong with doing the butterfly method, and I may even choose to do that, but what a lot of students do when they look at number 4 is they're like, well, if I do a subtract 5 and a subtract 5, it would now look like this. You cannot just add or subtract things to get a common denominator. You can only multiply. And so we have a couple different ways to do this, but I think that the butterfly method is going to be the easiest. So let's do this together. X plus 2 times x minus 5. That's this first diagonal, and the first diagonal always goes from left down to the bottom right. Then I'm going to leave a little space, and I'll do the second diagonal, which is 2 times x. In between will always be this part of the butterfly, which happens to be a plus sign. And on the bottom, I'm going to push them together, x times x minus 5. I'm going to start by foiling the numerator on the left-hand side. I'm going to go through it pretty quickly. So remember, FOIL is front, outside, inside, last. Front, outside, inside, and last. And then over here we have a plus 2x. On the bottom, there is no reason, I want to say this again, there is no reason, you'll see why when it comes to graphing and simplifying as we get into harder problems. We're going to leave it just as is, and I want to just simplify the numerator. So x squared, okay, I've taken care of that because there's no other x squared terms. Negative 5 and positive 2 is a negative 3. And negative 3 and positive 2, so negative 3x, positive 2x, is a negative 1x. So before I can ask myself, am I done, I really have to ask myself, can you factor the numerator? So this particular numerator cannot be factored, which means if I can't factor and see if I can simplify it, I'm done. I'm good. Let's look right now at number 5. Let's look at number 5. I want you to start right now by factoring this denominator. You have 30 seconds. Begin. Factor the denominator. Maybe it's not even factorable. My process is, are there two numbers that multiply to give me negative 20 and combine to give me negative 1? There is. 4 and 5. They're different signs, and the larger of the two will be negative. So I'm going to do bottoms up. I'm going to do x plus 4 and x minus 5, and then I have to divide by the hidden 1. Well, dividing by 1 doesn't change anything, so I still end up with, in this case, I have 3 over x plus 4 and x minus 5. Subtract x over x plus 4. So we have two choices in how we're going to approach this. We're going to approach this either using the old school method or using the butterfly method. Okay, who says I think butterfly method is the easiest method here? Okay. Who says the old school method I believe is the easiest method? And who says I just don't know? Well, I will tell you, if you use the wrong method in this case, it probably will take you 2 to 3 more minutes to do the problem, because you are going to have to simplify multiple and multiple times. In this case, the easiest method is going to be the old school method. And the reason why is I want the denominators to look exactly the same. And if they don't, I am allowed to multiply in order to try to achieve that. So does everybody see how they both have an x plus 4? What does the right-hand denominator need to look just like the left-hand denominator? An x minus 5. Now, whatever I attach to the denominator, I must also attach to the numerator, so it doesn't change this basic equation. Now, they look exactly the same. So in the denominator, I have x plus 4 and x minus 5. Now what about the numerator, where there's a left side and there's a right side, and they happen to be separated by a subtraction sign? So on the left side, I have a 3. On the right side, I'm going to distribute. I have an x squared minus 5x. And similar to number 4, I'm going to start by writing this in what's called standard form. This is standard form, x squared, x, and then just the value that has no x as the constant. So when I distribute this negative sign, it was subtraction, x, I get negative 1. I get negative 1x squared. When I distribute, a negative times a negative is a positive, and I had a positive 3 out front. With the help of your partner, I want to know, can you take this trinomial and factor it? That means, can you think of two numbers that multiply to equal negative 3 and combine to give you positive 5? Talk to your partner, please. Go ahead. It's not factorable. I can't think of two integers that multiply to give me negative 3 and combine to give you positive 5. What does that mean? Doesn't mean you did it wrong. It means I can't factor it then to see, can I simplify more? And we are done.